So our next speaker is going to be Chris McCahill from SSTI, who's going to talk about big data and transportation systems. So I'll turn it over to Chris.
So my name is Chris McCahill. I'm with a group here on campus called the State Smart Transportation Initiative. We work mainly with state departments of transportation. So not specifically a lot of city-oriented work, although we have worked with cities and we do think about cities a lot. The way my group works actually is by convening a network of the leaders of state DOTs from a dozen or so states around the country. We get together once a year. We do a lot of technical service for those folks. And we just had our big meeting with 17 different states in Boston about a week ago. And with the folks that are directing the state DOTs, and obviously they're talking a lot about these things like autonomous vehicles, traffic safety is a big one. What I really wanted to talk about was the way that they're starting to think about using data and technology to leverage in their decision making. You know, understanding how do we make sure the state is running the way it needs to, and what can we be doing to maintain our infrastructure better. What do we need to build, and things like that. So I'm just going to focus on two big questions that we see data and data analysis playing a big role in. The first one is trip making patterns. So just understanding where and how are people traveling. And the second one is access to opportunities. So this is the question of how easily can people get where they need to go. And I think this is an important one because it's reframing how we think about how our transportation systems serve people. Is it actually getting them the places they need to go, which is what our transportation system should be doing. So we'll just start with trip making patterns, understanding how and where people are traveling. This is being done through a lot of new data sources. A lot of this data is coming from in-vehicle GPS units, mobile devices, smartphones, mobile apps. And it's letting us basically track the movement of people on a pretty fine-grained level from day to day. This kind of data is coming from a bunch of different providers. I won't list them all here. We've worked with a handful of them. But we work mostly with this company called Streetlight Data that's based in San Francisco. And what they do is they kind of look around for all kinds of different data sources. You know, you've got cellular data that is sort of low resolution because it's just kind of understanding roughly where you are based on your relationship to cell towers. At the very high resolution end of the spectrum, we've got GPS data. And then there's these newer things that are kind of filling in the middle, like location-based services. So this is when you're running an app on your phone, it's telling your location, and it's using all kinds of different technologies to do this. So a company like Streetlight Data now claims that they have a sample size of about 25% of the adult population in the country. And they're harnessing this data using algorithms to understand how people are getting around, how long their trips are, what routes they're taking, what modes they're using, and all kinds of things like that. And then basically commercializing the data so that folks can make decisions with it. We use this data for a case study in Northern Virginia. This was actually one of the first states that was like, we've heard about this big data stuff, how can we use it to make decisions? So we bought a big package of data for Northern Virginia. It was 800 analysis zones. And then we basically went through the data and we were looking for opportunities to reduce car travel. Because the way that they view things up there is that we've already built out our highways. We can't keep making them wider and wider. We need to figure out how to use them better, right? And a lot of that is getting car trips off of them when they don't need to be car trips and giving people other opportunities. So we looked through the data for things like large flows between two zones, right? Because if a lot of people are going from the same point A to the same point B, maybe they could be taking transit, maybe they could be carpooling, things like that. Lots of short trips. If we see, you know, lots of 1 or 2 mile trips in a certain area, those are trips that could be made by walking or biking, but maybe there's something that's preventing people from doing that, right? Maybe the roads are just really dangerous or there aren't good connections to where they need to get. And circuitous trips. So this means that the distance that someone traveled is much longer than the crow's fly distance. So that means they're going way out of their way to get there for some reason. It could be that there's an obstacle in the way. It could be that the roads are just really disconnected, like a lot of these cul-de-sac neighborhoods, where you're really only going a quarter mile, but you have to drive 3 miles out of the way to get there. That means things like walking and biking aren't an option. but you could provide that connection. So these are the kinds of things we were looking for. Here's an example of one of the things we found. You can see where this metro station is. That's Van Dorn Metro Station. And just looking through the data, we saw there's several thousand daily trips to and from that station to the neighborhood just to the north there, less than a mile away. And a lot of those trips are circuitous. That means people are going, 3 miles when the total distance was just 1. So we dug in to find out what's going on here and what can be done about it. As it turns out, the only way to get from the station to those neighborhoods is this road. So obviously not very walkable and bikeable. And it also means that all this traffic to the station is causing traffic on this single road for all the commuters during the busiest times, right? So that's a problem. We identified this problem just by digging through the data. Once we raised it, the Virginia Department of Transportation was not surprised to hear this. They already knew there was a connectivity problem. They'd already been talking about potential bicycle and pedestrian problems, connections, like a pedestrian bridge or something like that, to allow people to get to that station without having to get in their car or without needing their partner to come and drop them off before they go to work, right? And basically add that option for people and get some of those cars off of that busy road. And just having the data to back this up sort of says to the Department of Transportation, you intuited that there was a problem here. We can actually put that into numbers. We saw about 1,000 trips a day. Maybe you could get half of those off the road, and you can actually quantify the impact. With this data, the company that provides that streetlight data is actually really trying to get ahead really quick about where can we take this data in new places. So they have a user interface. If you're one of their clients, you can go in and use their traffic busting tools where you can say, on a particular road, let me understand the traffic a little better. Like, let me see what kind of traffic, what levels of traffic there are at different times of the day. And then let's say I want to look at that evening peak traffic, and I want to understand what's the distribution of those trips by trip length, right? And in this case, you can see that like a quarter of the trips are under 5 miles. What's the distribution by trip purpose? Is it people going to work? Is it other kinds of trips? And breakdown by income, right? So what's the income distribution of folks on that road?
What do those stand for? WBO, OBO?
That would be like, HBO is home-based other, HBW is home-based work. So that's just the type of trip. And then the other thing they're doing is kind of developing these tools to say like, well, we know a bunch about the traffic. Can we sort of recommend some potential solutions that don't involve, widening the road by looking at the characteristics of the traffic? And we can say, maybe this is an opportunity for biking or walking. Maybe trucks are a big part of the problem. Maybe it's an opportunity for transit because, like I said, we've got a lot of those people going from the same point A to the same point B. And this doesn't give you the answer, right? But it starts to point you in the right direction of how to think about addressing some of your traffic solutions in new ways. A very exciting, very new thing that's going to be released later this year, hopefully, is multimodal data, right? So they've got enough data by now that they can run these algorithms and say, well, we think we can pick out what were car trips, what were people walking, biking, taking transit, and so on and so forth. And we did a pilot of this with them a couple years back with in Sacramento. So how might you use this data? What we did in Sacramento, we were interested in basically understanding transit ridership. So what we did was we took the data and we said, hey, streetlight data, can you tell us that Zinfandel station there, circled in yellow, can you tell us all the folks that you saw walking to and from that platform, where did they start their trip, right? So you see the really dark purple areas, 35% of the folks came from there, 28 came from there. We dig in and we can say, well, that's actually where there's some shopping centers. I think there's a Target, another shopping center. So we can say a lot of people that are using transit seem to be visiting those shopping places. The lighter color areas around the edge are residential areas. So some people coming from the residential areas, not as many. And then this, the 15% strip down at the bottom is really interesting because it's an office park. But the only way to get there is walking through that highway interchange there. So we see that actually 15% of the people to the transit station are coming from this office park, walking through this highway interchange, right? So probably a good opportunity to improve the pedestrian connections to that station. A, for the people that we can see are already making that trip, and B, so we can probably get a lot more commuters to that office park accessing that transit station. And we can, there's going to be ways of digging into each of the individual traces we see and understanding behavior in a lot better ways. This is one of the more interesting traces that they were willing to show us, that shows someone meandering down the street. They're confident that this is someone's actual behavior and not just sort of like bad pings. But you can start to understand things like, where are people crossing the road where there isn't crosswalks, and do we need to address things like that, and all kinds of interesting questions. So that's the trip making data. That's understanding how and where people are traveling in real life. The second opportunity is measuring access to opportunities. And as I mentioned, we think this is a really important way to measure transportation system performance that a lot of agencies are starting to think about. We call this accessibility a lot of the times, but accessibility can be a confusing term because it means different things to different people. But why measure accessibility? Well, the way we currently measure how well the transportation system is performing is usually just to look at a single point in the network, look at a single road, and say how fast the car is moving, what's our vehicle throughput. So is that little piece of the road functioning the way we expect it to, right? But that doesn't tell us anything about where people are trying to get, where they came from, what mode they're using. It's basically just saying how fast is that road moving. What accessibility does is it says, well, we need to know a little bit about people's origins. We need to know about people's destinations. Those could be jobs, could be other opportunities, and we need to understand people's ability to travel between them. So in this case, the speed of the road might be important, especially for folks that are driving in from out of town. But for someone that lives just down the road, a 5-minute commute, the speed of the road probably isn't that important. It's not going to affect their total travel time that much. And then there's also people that are trying to cross that road, often by walking or biking or by driving. So there's all these sorts of connections that we need to make sure we're accommodating. And we can make sure we're doing that if we measure accessibility instead of just things like vehicle throughput. To do this, we need a lot more information than we're traditionally used to working with. So that's one of the biggest obstacles to making this leap. We need to know where all the roads are, what the vehicle speeds are on the roads at different times of day, which, as I just showed you, we can now do with new sources of data. We need to know where the bike paths and sidewalks are, where transit runs, how often, and all those things. We also need to know the land uses, which is another new important piece of information. So where do people live? Where are they trying to get? And how is our transportation system facilitating those connections? And then we need a way of calculating accessibility. So we use a tool called Sugar Access by City Labs. It's a commercial tool. It's another cloud computing platform. So this wouldn't have been possible. People have been talking about accessibility for a long time. It's just recently been possible for folks to just sort of measure it. And the way it works is we just manipulate the data, package it up, and send it off to the cloud. The calculations are done, and then it comes back to us. So this is one of those examples. And here's what accessibility looks like. This is a heat map of Madison showing access to jobs by driving. And the question we're asking is, for any given zone, any given block, how many jobs can folks reach by driving in the typical morning conditions? Because we know how fast cars can move in the morning. And this is what it looks like. You can look at a certain household and see that, oh, they can reach 29,000 jobs within 15 minutes. 203,000 within 30 minutes. They can pretty much reach all the jobs within 45 minutes. And we usually report some weighted number where the really close jobs get more weight than the ones that are really far away. We can do the same thing with transit. And you see transit accessibility, as you'd expect, isn't nearly as good. It's best near the job centers where you don't have to actually travel that far, and along the busiest transit routes. So that same person now can only reach 250 jobs within 15 minutes by transit, 24,000 jobs within 30 minutes, and so on and so forth. So we would report their transit accessibility is about 18,000 jobs. Yeah?
Are these maps public?
They are now. Yeah, we've got them. We've showed these a lot. You can contact me and we can share them with you. Another thing you can do with this then is start to evaluate transportation projects. So this is the Route 31 bus line that was added 5 or 10 years ago. And what we can do is say, how did that affect people's accessibility from before and after? So we can look at someone that lived down where that bus line now runs and see that before, let's use the 45-minute number. Before, they could only reach 3,000 jobs, and now they can reach about 35,000 jobs by transit. So this is a way of understanding how a transit project might impact people. And if we were using this tool to evaluate different transit lines or different transportation options, we could say, which one has the biggest impact, right? Which one should we be investing in? You can summarize, the total impact of this project was 1 million household jobs, or the average impact was an extra 5 jobs that people could reach across 200,000 households. So this is what agencies like the Virginia Department of Transportation are starting to do, actually saying, which projects are we going to fund based on how much they improve accessibility. So that's actually being done. And I think there's well, I won't go there yet. We can also do this by walking, biking. So this is a map of walking accessibility. This shows how easily it is for people to walk to all kinds of different destinations. If anybody's familiar with Walk Score, this is doing the same thing as Walk Score, except we can sort of manipulate the data and what it's measuring. And we could measure how a pedestrian project might improve walking accessibility. One of the problems with this one is that this has pretty general assumptions about what's walkable and what's not walkable. So we don't really know a whole lot about, should this street not be considered walkable because it's dangerous, there's lots of traffic, it's unpleasant for pedestrians. So this is making really general assumptions about what the walking environment is. And I think that's a good area for understanding the environment a little better. So areas that need a future work, like I said, understanding the factors that affect walking and biking accessibility, traffic, road design, etc., so that we can measure walking accessibility more accurately. Understand how things like parking affects accessibility for drivers, how tolls and fees should be worked into accessibility. Reliability, right? If it takes you 15 minutes one day and 30 minutes another day, how do you factor that into accessibility and things like that? And then relating it to outcomes. So if we know someone has really poor transit accessibility compared to their driving accessibility, then they're probably not going to take transit, right? So we can understand, using these metrics, if we build a transit line, how likely are people going to be to use transit, because we know how easier it is for them to drive versus choosing transit. We can predict how much people might walk or bike, predict health outcomes. Accessible places tend to be very desirable and economically productive, so we can start to predict economic activity and things like that. And I just want to end by sort of a little overview of how we think about this kind of stuff fitting into the decision-making processes. This is kind of the level that we work with the agencies at, is kind of understanding how this data affects what you do. So we can scan existing conditions, we can understand the environment a little better. We can diagnose problems, right? If we see low accessibility, we can understand what might be causing that. And then we can assess solutions, right? So how does this bus line improve accessibility? Or how does this bike or pedestrian path improve accessibility? We can engage stakeholders because these kinds of maps tend to be a lot more intuitive to folks than the tools that a lot of transportation agencies currently use. I can tell you this project will increase your access to jobs by 20,000 jobs, and that kind of makes sense to people. We can track performance over time, so if we measure this year to year, we can see, are we meeting our goals of improving accessibility or health or economic activity? And as I said, predict outcomes. So that's how all this fits in, and that's all I've got.